Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is two hinged arches. In analysis of structures, this is the one of the topic which is very important for doing some of the constructions like bridges. In this type of arches, we have to understand how load conditions are distributed based on the number of hinge. So we have different types of arches are available according to their geometry, according to the material available, according to the hinges. So according to the hinges, we are again classified them as two hinged arches as well as three hinged arches. So whenever the arch has two hinges at their supports, such type of arches is known as two hinged arches. And one more arch is at crown. Such type of arches are known as three hinged arches. Here in this particular topic, we are going to understand about the what kind of mechanism is there for two hinged arches, how we are understanding those type of arches for analysis, and how the support is distributed as per the given loads. These are the parameters which we are going to understand in these two hinged arches. Here, this is a structure. We are used in engineering as well as architecture. As a civil engineering, we are used these type of arches whenever to reduce the internal stresses and also due to thermal expansions and also other deformations, we have to support for the structures. Whenever it is there, those situations, we are choose these type of two hinged arches. It is a type of arch and also here it has two supports by two hinges or pins at its base. So one on each end. These hinges allow the arch to rotate slightly at supports, which helps to reduce the internal stresses, especially due to the thermal expression or other deformation. And in this, for key characteristic, these two hinged arches, these two hinged provides rotational freedom. It gives the rotational freedom to the structure, which makes the structure determinate. It means any structure, it should be statically determinate. It means equilibrium conditions are enough for getting the unknown parameters in that particular arch, in that particular structure. Such type of structures are known as statically determinate structure. Here, two hinged arch is the one of the example for this statically determinate structure. Statically determinate structure. So, based on the equilibrium equations, what are the equilibrium equations? We know those are along the x-axis or along the horizontal forces. Some of the horizontal forces should be 0 and some of the vertical forces is equal to 0, and also the movements along these loads according to the loads. So how many movements we are getting? So that movements, the sum of the movements should be is equal to 0. These are the equilibrium conditions we are getting for this. These are the equilibrium, statically equilibrium conditions. So these three conditions are enough for unknown parameters in any type of structure. Those are known as statically indeterminate. So here our two hinge arch is statically determinate structure. Here the internal forces can be determined. It means the unknown parameters are internal forces. So these internal forces can be determined using equilibrium conditions alone. No need of any additional equations for knowing about the internal forces in that particular structure. Such type is known as statically determinate. And load distribution. The arc efficiently transfer loads primarily through axial compression along the curve of the arch. So here we know the curve of the arch. These are the two hinges are provided at both the ends. And here the curve of the arch. So whenever the arch efficiently transfer the loads axial compression along the curve of the arch, reducing the bending moments compared to the simply supported beam. Once we compared with these, so we may provide simply supported instead of these arches also. So we are having this kind of advantage. So we are lost this kind of advantage. Once we provide instead of simply supported to these two hinged arches, we are going to reduce the bending moments of that particular structure. So like this, the load distribution is also one of the key characteristics of our two hinged arches. Structural support and also the load distribution. So in this, what kind of material we are using for getting these construction are also important. That gives the material efficiency due to its shape and load distribution. A two-hinged arch can be constructed using less material than a traditional beam while achieving the same span. So, for same span we are required. So, for beam, traditional beam we are providing, instead of that we may provide this arch. Due to its shape, the arch has its unique shape. It requires less material. It requires the less material whenever we are doing the same span length we are using. So for construction of arches requires less material. So this is also one of the characteristics which we are understanding. So the material efficiency is there. And also some of the common applications we may observe in these arches. Two hinged arches often used in bridge design, roof structures and large span openings. So in this, the structural efficiency is important in any such type of cases. So using these type of arches, we are getting the structural efficiency in these longer spans, bridge designs and roof structures. These are the examples where we use this type of two-hinged arches. And how we are analyzing these two-hinged arches? In this, the analysis involved based on the reactions. So these reactions, according to the reactions as per the condition statically determinate, statical equilibrium equations are enough. Sum of the horizontal forces, sum of the vertical forces is equal to 0, and the sum of the moments present in that particular structure should be 0. Calculating these directions, we are going to find out the axial force, shear force, and in some of the cases bending moments also whenever it is required. It depends upon the given data, or it depends upon how we are going to analyze based on the known data. And also two-hinged arch is analyzed using the principle of static equilibrium, that is there using these conditions. Geometry of the arch, it depends upon the size, shape, whether it is parabolic arch. Shape, it means whether it is maybe parabolic or circular. It depends upon the shape. And size, it given how much diameter, length of the span, and where the at which point the load is acting, and in some cases compatibility equations to consider this deformation. So as per we are analyzing, we have to follow the static equilibrium and also the geometrics of the what are the size of the arch and also length, what type of shape we are considering. These are the parameters we are going to understand for getting the analysis of these two hinged arches. In this, move on to the advantages. Here, the stability. So the two hinged support systems provides stability while allowing for some movement, accommodating changes in temperature or load without inducing the high stress concentrations. In this, arches are visually appealing and often used in architectural design for their elegance and simplicity. And also, we have some disadvantages in these two hinged arches. In this complexity, it is complexity in construction. Construction, that is building an arch, especially one with prescribed curvatures, can be more complex and costly compared to the simple beam structures. So this is the one of the disadvantage we may observe in these two hinged arches. So according to that, we may understand what kind of analysis we are going to do using the numerical values. Here, a two hinged parabolic arch. Here we have to understand the question. Two hinged parabolic arch has a span of 30 meters and a rise of 10 meters. The arch carries a uniform load of 20 Newton per meter over its entire span. Determine the horizontal and vertical reactions at the hinges. Here it is a two hinged parabolic arch. There is nothing mentioned about the supports are whether they are in same axis or not. So here we are considering they are in same axis. So they are in same axis. And also the span length is in 30 meters. The length of the span. Length of the span is 30 meters and a rise, it is from middle point from here to here, that is equal to 10 meters. The rise is 10 meters. Here and also the over entire span may understand like this, but we are representing like this. So entire span, uniformly distributed load. So entire span, that is equal to uniformly distributed load 20 kilonewton per meter. This is the given problem. Properly we are going to draw for understanding this problem. Roughly I draw this one now. From one parabolic arch, two hinges are at the same axis. From here to rise, that is equal to 10 meters and the span between these two hinges is equal to 30 meters. So the overall uniformly distributed load to entire span, that is equal to 20 kilonewton per meter cube. So 20 kilonewton per meter for its entire over span. Now before understanding these vertical and other supports, for finding these horizontal and vertical reactions, first we have to know about the total load. Total load is nothing but the uniform load. It is uniformly distributed load. So uniformly distributed load multiply the how much span length. So here uniformly distributed load is 20 kilonewton per meter multiplied by 30. It is total load is equal to 600 kilonewton. So once we get this total load, that is equal to W. Now we are going to find out the reactions. So now we are going to find out the reactions at supports. So here, since the load is uniformly distributed and the arc is symmetrical. This is symmetrical one. This is symmetrical. The vertical reactions at both hinges will be equal. So because it is the symmetrical one. Now the vertical reactions VA, VB is equal to W by 2. So here total load is equal to 600 divided by 2 is equal to 300 kilonewton because of the arch condition is symmetrical. That's why the vertical reactions at the both the supports are equal. So VA, VB. In some of the cases there may be RA, RB they may use, it depends upon the reference. So the notation may differ. V in some of the cases, we may use R also the vertical reactions. So here because of the symmetrical of condition, so both the vertical reactions are equal. We have distributed the total load to equality because of the symmetrical consideration of the arch, and also the overall the load is also distributed equally. It is a symmetrical conditions for a parabolic arch. So that's why we are getting the vertical reactions are same. Now determine the horizontal reactions at supports. So for two hinged arches, here because of the symmetrical conditions, the horizontal reactions for both the conditions is equal to same here. So that is the horizontal conditions. So this is HA and HB. So for finding these horizontal reaction, the sum of the forces is equal to 2 taking moments about point A. We are considering whether we are considering taking moments from A or taking moments from B. We may consider that is equal to H into H minus moment of the load. So the moment of the load about point A. So W multiplied by L by 8 for a parabolic arch. So here L is equal to 30 meters, H is equal to 10 meters, that is equal to 600 into 30 by 8 is equal to 2250 kilonewton meter. So equating the moments, H into 10 is equal to 2250, that H is equal to 225 kilonewton. So like this we are finding the moment of the load. So we know the moments with respect to A. Along the moments with respect to A, the load is going to distributed VL by 8 for parabolic arch. We know L is equal to 30 meters, H is equal to 10 meters. Calculated finally we get the horizontal reaction. So that is equal to 225 kilonewton. Like this we are finding the various reactions. Now move on to for the same two hinged parabolic arch. So once we understand as per the previous problem, same two hinged parabolic arch, calculate the internal axial force, shear force and bending moment at a point located 10 meters from the left support. So this is the same symmetrical. Overall entire span is equal to 30 meters between the two hinges, and the rise is equal to 10 meters. Uniformly distributed load, that is equal to 20 kilonewton per meter, and already we find out the vertical reactions, that is equal to 300 kilonewton. Horizontal reactions is equal to 225 kilonewton. From the left hinge, here what they asked from left to here, from 10 meters, from here to here, to consider 10, maybe somewhat distance is there. Okay, 10 meters from here to here we consider. So find out the axial and shear forces at this particular point located from the left hinge from A. Consider this is A and this is B, from left side to this is. So here the arch is symmetric. So that the point from axis here consider this is equal to X. From here to X, that is equal to X is equal to 10 meters. Calculate the vertical reaction. Already we found these vertical reactions and horizontal reactions are there from problem 1. Now move on to the calculate the height of the arch at 10 meters from here. What are the internal forces involved in this? For parabolic arch, we know the formula for this parabolic arch. So at any point X, Y is equal to H 1 minus 4x square by L square. So in previous already we studied this formula. Now calculate according to the known values. Here h is equal to, we know that is equal to, h is equal to, we know that is equal to 10 meters. Here the rise, that is rise is equal to h, 10 meters, and 1 minus 4 into x is also 10 meters. L is equal to 30 square. Don't get confused here. H is equal to x is same. Sometimes it may not be same. H is belongs to the vertical one. It is the rise, the highest point of the arc to the base. Height of the crown from base. So crown, it is nothing but the highest point from base. So no need to write this. So height of the crown point, wherever the crown point is, that is nothing but the h, that is nothing but the rise. Here h is equal to, y is equal to, this is the formula, h is equal to 10 meters and x is equal to also 10 meters. We are asking about 10 meters. What is the situation? Overall span is equal to 10 meters. So now, finally after substituting all the values, y is equal to 5.56 meters after calculations are done. So after that, now we are going to find out the moments. What kind of moments are there in that particular point? So the moment we are going to at point A can be calculated, that is equal to MA. Moments with respect to A is equal to HA into Y minus load moment. MA is equal to HA into Y minus load moment. So load moment for x is equal to 10. So load moment is equal to uniform load into x into length divided by 2. So here load is equal to 20. We required from only x, that is from x, from A to x is 10 meters and length is equal to 10 meters from there and divided by 2. So here that is equal to 1000 kilonewton meter. Substituting this M10 is equal to 225 multiplied by the height, y is equal to 5.56 minus 1000, that is equal to 251 kilonewton meter. Moment is there at this particular point. Like this, we are going to understand the various problems which we are going to use in this particular two-hinged arch. And move on to this axial force, shear force and bending moment at x is equal to 0. Here axial force is equal to HA, N is equal to HA is equal to 225 kilonewton. Shear force, move on to the shear force. So V is equal to VA minus load on segment, that is equal to 300 minus 20 into 10, finally that is equal to 100 kilonewton. Bending moment already calculated in the step 5. So this is equal to 251 kilonewton meter. So finally summary, for these internal forces at x is equal to 10 meters, axial force is equal to 225 kilonewton, shear force is equal to 100 kilonewtons, bending moment is equal to 251 kilonewton meter. Now move on to the another problem for the same two-hinged arch. Determine the location and magnitude of the maximum bending moment. For the same problem, it gives the better understanding. That's why I consider the same problem for different unknown calculations, or different internal forces, or what are the movements are there in different scenario for the same problem. So here calculate the bending moment equation for any point x on the arch using the equation for the moment m of mx h into y minus load moment, where y is equal to h 1 minus 4x square by L square and load moment so that is equal to W into X into L minus X by 2. So substitute y, m of x is equal to 1 minus 4x square by L square. So here that is equal to W into X into L minus X by 2. And after calculations, we know with respect to the X, once we required these maximum bending moments, that is the differentiation with respect to X should be 0. So now we are going to differentiate and solve that equation. We get X is equal to 15 meters gives the required thing. Now, see, we know this, and now calculate the maximum bending moment at that particular point using the similar formula. Finally, that is equal to 2100 kilonewtons. When the maximum bending moments occur at the midpoint because of the symmetrical condition of the given arch, given parabolic arch. And the maximum bending moment occurs at the midpoint of the span, and that is equal to 2100 kilonewton meter. Like this, we are going to understand the various parameters in the parabolic arch. So according to these are some of the references which we are going to follow for a better understanding about these arches. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.